Good day, I am Vero Guyana, ID 125, and I will be teaching FNDMATH LQ3. This LQ will focus on trigonometric functions and applications of trigonometry, more specifically on angles of elevation and depression. Let's start with a review of the six trigonometric functions, which are sine, cosine, tangent, cosecant, secant, and cotangent. And these ratios help us to find the values of any given angle or side of a right triangle. We can use these functions to solve the triangle ABC. Here we can see that angle A is equal to 30 degrees, angle C is equal to 90 degrees, and therefore angle B would be equal to 60 degrees. So this is a special kind of right triangle. We are to solve for side A and side B. So how do we start? Well, we're given one side, which is 12, the hypotenuse. And which functions have the hypotenuse? These are sine and cosine. So depending on which one we're looking for, we have to think about which function we're going to use. For side A, we would be using sine, because this is opposite the angle 30. So for side A, using sine of 30 degrees is equal to the opposite side, A, what we're looking for, over the hypotenuse, which is 12. So we can multiply both sides by 12 in order to isolate A. So that would be A is equal to 12 times sine of 30 degrees. And sine of 30 degrees is simply 1/2. So this would be 12 times 1/2, or 6. So side A is equal to 6 units. How about for side B? Let's erase this. For side B, we would be using cosine, because we have the adjacent side over the hypotenuse. And with side B, this is adjacent to the angle 30, and we have the hypotenuse still. So this would be cosine 30 degrees is equal to side B over 12. And we repeat the same steps. 12 cosine 30 is equal to B. And cosine of 30 is √3/2. So this would be 12 √3/2. Simplify 6. So B is equal to 6√3. And that's how we can use these trig ratios. Let's start with the problems involving angles of depression and elevation. The angle of elevation happens when you're looking up at an object. So let's say you're looking at the sun. The angle you make between the ground and the line from which you're looking at, that is your angle of elevation. And then your angle of depression is when you are looking downwards. Let's say this is an eye, and then you're looking down at a ball. And then this is your horizontal line of sight. The angle between that and the line that you're looking down towards, that is your angle of depression. And if we extend this further, we can make an angle over here. And we could notice that these two would be congruent because they are alternate interior angles. And this here looks like an angle of elevation. Now let's see what that looks like in this problem. From the top of a 200-foot lighthouse, the angle of depression to a ship in the ocean is 23 degrees. How far is the ship from the base of the lighthouse? So, this is your 200-foot lighthouse. And this is the ship. This is your horizontal line of sight. And this is the angle, 23 degrees. The lighthouse is 2,200 feet. And we are looking for how far the ship is from the base of the lighthouse. This is your x. This is a 90-degree angle. And this here is congruent to the angle of depression. So, which trigonometric function do we use in this situation? We have the angle adjacent, the side adjacent to it, and the side opposite to it. This would be tangent. So tangent 23 is equal to the opposite side, 200 over x, which is your adjacent side. So we need to isolate x. Can do this by dividing both sides by 200. So this would leave us with 1 over x is equal to tangent 23 over 200. And then just take the reciprocal. X is equal to 200 over tangent 23. And we could just input this. So 200 over tangent 23. This would give us approximately 471.17 units. And this would be in feet because the lighthouse was 200 feet. And this is your answer. Let's move on to our next problem. A 20-foot ladder leans against a building so that the angle between the ground and the ladder is 72 degrees. How high does the ladder reach on the building? So this is the building, and this is the ladder. This is 20 feet. And the angle between the ground and the ladder is 72 degrees. This here is 72 degrees. So this is an angle of elevation problem. You are looking for how high does the ladder reach? This, the height, would be your x. So you are given an angle, the hypotenuse, and the side opposite the angle. The trigonometric function you would use here is sine. Sine 72 degrees is equal to the opposite over hypotenuse. So x over 20. You would isolate x by multiplying both sides by 20. So x is equal to 20 sine 72. And just plug this in again. 20 sine 72. This is equal to approximately 19.02 feet. And this is your answer. Next problem. A 600-foot guy wire is attached to the top of a communications tower. If the wire makes an angle of 65 degrees with the ground, how tall is the communications tower? So let's draw this first. This is the tower. And there's a wire attached to the top. Makes an angle with the ground. This over here is 65 degrees. The wire is 600 feet. And how tall is the tower? This is very similar to the last problem. You have the angle, the hypotenuse, and the opposite side. So you would be using sine. Sine 65 is equal to the opposite side, x over 600. Isolate x by multiplying both sides by 600. X is equal to 600 times sine 65. And then we just plug this in again. 600 times sine 65. This is approximately 543.78 feet. And that's it. Let's try a different problem. A giant redwood tree casts a shadow that is 532 feet long. Let's say this is the tree. And then this is its shadow. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. So if there's the shadow, the sun would be over here. And then the angle of elevation this is 25.7 degrees. The shadow is 532 feet. And we're looking for the height of the tree. This is x. We have the angle, the side adjacent to the angle, and we're looking for the side opposite to it. So in this problem, we will be using tangent. Tangent 25.7. Wait lang. I will. Tangent 25.7 is equal to the opposite over the adjacent sides. The opposite side is x, and the adjacent side is 532. So to isolate x, we will be dividing both sides by x. So to isolate x, we will be multiplying both sides by 532. We just cancel here. And x is equal to 532 times tangent 25.7 degrees. And if we put that into the calculator, 532 tangent 25.7 that would be around 256.03 feet. So this would be the height of the tree. Next problem. From a point on the ground 500 feet from the base of a building, an observer finds that the angle of elevation to the top of the building is 24 degrees, and that the angle of elevation to the top of a flagpole atop the building is 27 degrees. Find the height of the building and the length of the flagpole. So this is 500 feet away from the building. This is your observer. The angle of elevation to the top of the building, this here, is 24 degrees. And there's a flagpole atop the building. That angle is 27 degrees. Find the height of the building. This is your x. And the length of the flagpole. We can say that this entire thing is y. And therefore, the length of the flagpole would be y minus x. So how do we start? We can split this into two right triangles. Should be this one and the other one. This would be 27 degrees, 24 degrees, and both would have 500, a base of 500, and their heights would differ. X and Y. Yes. We can start with the larger triangle. So we have the angle, the opposite, and the adjacent sides. So this would be tangent. Tangent 27 degrees is equal to opposite over adjacent. So y over 500. And then just multiply both sides by 1. 500, and that would be y is equal to 500 tan 27. And we can plug this in. 500 times tangent of 27 degrees is equal to around 254.76. For the second triangle, we would be using the same process, except two different values. Tangent of 24 is equal to x over 500. So x is equal to 500 times tangent of 24 degrees. And if we plug this in, 500 times tangent of 24, we would be getting around 222.61. So we are looking for the height of the building. The height of the building is equivalent to x, and that would be 222.61 feet. And the length of the flagpole is equivalent to y minus x. Y is 254.76, and x is 222.61. Should be 5, 1, 2, 3. 32.15 feet. And these are your answers for the last item. Thank you so much for watching. You may also avail syntax tutorials by scanning the QR code flashed on your screens. Once again, this is Vero Guyena from Syntax, paving your way to excellence.